what we can use KSP for is we can find out, is a solution saturated? And what that means is, have we dissolved as much as we possibly can dissolve into this solution, or into this liter of water, or into the ocean? When will things start to precipitate? And again, this would be looking at, can you precipitate the shells? You know, when are shells going to dissolve? It would also be looking at if I had lead. Actually, when I'm doing a demonstration, unfortunately, lead makes some really pretty colors, so I like to use it, but I don't like to have a high concentration of the lead. So to get the lead to precipitate, I will use a high concentration of chloride and a low concentration of lead, and then I reduce how much of the lead I'm using, because it's not good for us. So I'm trying to find out if a solution is saturated. KSP tells us the maximum amount of solubility we can have. It tells us the maximum amount of the product of the solubilities can be. So that is the concentration of one thing multiplied by the concentration of the other. It tells us the maximum number that can be. So if you want to know, do I have a saturated solution? You are questioning if you have a saturated solution, you're going to calculate QSP. QSP, again, is the same as KSP. It's just that you're not plugging in equilibrium values. So you're plugging in, these are the values I have. Am I at equilibrium? Plug them into the K expression. And if QSP, your question, your current values, if they end up being larger than the KSP value, that means, well, it's always products over reactants. It means you have too many products. So you have too many ions being dissolved. You're going to have to shift left to get back down to KSP. So you're going to make a solid. You're going to precipitate. If QSP equals KSP, okay, you're at that equilibrium. It means that the solution is saturated. You have the maximum amount of ions dissolved that you can have before they start colliding and then turning into solid. If QSP is less than KSP, it means the product, which is your ions that are dissolved, is lower than what it can be. So you can actually dissolve more solid. So your solution is not saturated. So let's see, do we have a saturated solution? I have some solid silver chloride. Another reason that we want to look at that is I don't want to dissolve too much of the silver because the silver is more expensive. So I want to know when is this thing going to start to precipitate? How much silver am I going to use? So some solid silver chloride is placed in 1 liter of water and is allowed to dissolve. The concentrations of silver and chloride are each 1.2 times 10 to the negative 5th molarity after the solid dissolves. KSP at this temperature is given. Is the solution saturated? Okay. So I'm questioning, am I at KSP? So what I'm going to do what I always do. I am going to write my balanced equation. This makes me feel good. All right. And I'm going to say I got some solid, and I'm losing some of it. And actually, I'm given the equilibrium amounts here. I'm given 1.2 and 1.2. So I know this is 1.2 times 10 to the negative 5th. So is this one. And yeah, it's given in the problem too. So 1.2 times 10 to the negative 5th. I'm just organizing my information so I can show what I'm doing. So I know these are my equilibrium amounts. I'm questioning if I'm at equilibrium. So my QSP expression is the same as my KSP expression. Concentration of this times concentration of that. So that's this guy squared. So 1.2 times 10 to the negative, that was 5. We square that. So my QSP is equal to 1.44 times 10 to the negative 10th. And I can see that this is my QSP. This is my KSP. QSP is smaller than KSP. So QSP smaller than KSP. That means I can have more here. So I can have more of these guys dissolving. It's not saturated. So no, not saturated is my answer. I could dissolve more silver chloride. Next. Now I have a solution. It contains a concentration of nickel ion. It's well worded there. Concentration of nickel ion at a concentration of 1.5 times 10 to the negative 6. If solid sodium carbonate is added until the concentration of carbonate is 6.0 times 10 to the negative 4th molarity, will a precipitate of nickel carbonate form? Ooh, nickel 2 carbonate. I'm excited. Let's see what that's going to be. I'm going to do what I always do. This is the thing that I'm looking at. Okay, I care about it. So nickel carbonate is made from nickel 2 ion much of those we have. And here we have, let's see, nickel 1.5 times 10 to the negative 6. And the carbonate 6.0 times 10 to the negative 4th. Alright, so if I have these amounts, I want to see if I'm at equilibrium or not. Do I have too many ions to actually be dissolved, so I'll have to shift back to this side and precipitate some solid, or could I dissolve more of these guys? So I question, am I larger or smaller equal to KSP? So that's this times this, because it's this guy times that. Alright, so 1.5 times 10 to the negative 6 times 6.0 10 to the negative 4th. Alright, so we multiply those, and I'm going to see the product is going to be 9 times 9 to the negative 10th. So 9.0 times 10 to the negative 10th. Okay, so that's my QSP. This is my KSP. So I can see, actually, QSP is smaller than KSP, right? Because that has more zeros in it before I get to that 9. So if this is smaller than KSP, again, I could fit more onto this side, so more nickel carbonate could dissolve. It's not saturated.